Welcome! In this video we will learn the basics of Unity through creating the classic Pong game. Everything you learn here should be useful in making almost anything in Unity. So let's just get started. So first we will just create a new project. You can call it whatever you want, but make sure to check 2D because this is a 2D project, and just hit create project. Next we will just create a new scene by clicking File, Save Scene, and just typing whatever name of the scene. I'll just call it game. Let's start off by creating a new empty game object. So just right click in the hierarchy and create an empty game object. Let's call it game manager. We will only need 3 scripts in this game. A script for the ball, a script for the paddle, and a script for the game manager. So just right click in the project and hit create a new C# script. And just rename it by hitting enter and typing whatever name you want to give it. In this case, game manager, paddle, and ball. We will also need some base shapes for our paddle and ball. So just hit assets, create, sprites, and click square. This will represent our paddle. That we can resize this later to turn it into a rectangle, and repeat this for a circle, which will be our ball. Let's actually create the ball by dragging the circle into the hierarchy and renaming it to a ball. And then we can add a collider by hitting add component and hitting box collider 2D. This is very important. We're not working in 3D. Make sure to enable isTrigger because that disables the default behavior of collisions in the game engine and allows us to fully customize how we want the objects to behave, and we will later on. We will also need to add a rigid body 2D component to actually register the collisions, but make sure to set it to kinematic so that Unity again does not use its own behavior with the objects. Now we will repeat the same process for the paddle. Just drag the square into the hierarchy so that it's a game object, and this time we'll move the X to the right a little bit just so it's different from the ball, and scale it down in width but increase the height so that it looks more like a paddle. I chose the value 0.5 and 2.5. Remember to rename it to a paddle. Add a box collider 2D to the paddle so we can also register collisions. Make sure to enable isTrigger like we did with the ball, and repeat the same thing with rigid body 2D, which must be kinematic so we can use our own physics. It's also a good idea to add a tag to the paddle so that in our script we know whether the ball collided with a paddle or something else. So in the inspector, hit add tag and hit the plus button and call it paddle. Then hit save. We should also do the same with the ball. Again, just hit add tag and call it ball. Make sure to actually assign the tag to the ball, and do the same with paddle. I forgot to do that. It's a really easy mistake to make. Now let's drag our paddle and ball to the project to turn them into prefabs that we can later instantiate. Make sure to reset the parameters for position of paddle that we set just to differentiate them visually. We can now delete the ball and paddle objects from the hierarchy because we can now instantiate them using the game manager script from before. So let's start coding. Drag the game manager script to the game manager object as a component and double click on the script. This should open MonoDevelop or Visual Studio or whatever editor you have. Unity comes with MonoDevelop, and we can now start coding. The game manager will instantiate a ball and a paddle, so we will need a variable for the script ball and a variable for the paddle. Public will ensure that we can drag and drop it into the editor. Now let's return to the editor and see what these 2 lines of code did. It'll take a while to load, but we will see that we now have an input for paddle and ball. If we try to drag in paddle and ball as it is right now, we will not succeed because our variables require it to have type paddle and ball. But to do that, we need to attach the script called paddle and ball, which we haven't done yet. So let's do that. Click on the paddle game object in our project and drag in paddle, the script. Repeat the same thing for the ball. Just drag in the ball script. If you did this correctly, we should now be able to drag in our paddle and ball into our game manager in the hierarchy. Right now, if we hit play, we won't see anything, so let's change that. Switch over to the game manager script and you will notice that there's a void start and void update. Basically, void start will occur at the beginning of the game, so anything you write here should run only once at the beginning of the game, and void update will update every single frame. So whatever code you write there will occur about 60 times a second, but that could vary depending on your hardware. Since our game manager will only instantiate for now, we can get rid of void update. We only need to instantiate the paddle and ball once. So to do that, type instantiate ball, which will use our variable ball, and instantiate a paddle. Don't forget to save the script. And if we hit run, you will notice that we have a ball and a paddle overlaid on top of each other. But that's a problem. We want two paddles to be in separate locations closer to the edge of the screen. So we will create two different instances, a paddle 1 and a paddle 2. We will need to make sure that it instantiates as a type paddle. This is essentially casting in C#. We will also need to be able to tell which paddle is left or right. So to do that, we will type paddle1.init to true. This is a function we haven't defined yet, but we will later on, and we will repeat that for paddle 2. True indicates that it is a right paddle, and false indicates that it's a left paddle. So to summarize what we've done, we've essentially created a ball, instantiated two paddles, and indicated which one is left or right through using init. Now let's go back to our editor and open the paddle script to actually create the init function that we just used. So to do that, just type public void init. It needs to be public so that our game manager can have access to it, and all we need is for it to take a boolean. Let's call it isRight paddle. A boolean, just as a refresher, is just a true or false value. If it is a right paddle, then we will set its position to the right of the screen. Otherwise, we will place it on the left of the screen. To calculate where to place our paddles, we will first need to know exactly where our boundaries lie. To do so, we will switch to Game Manager and create two vectors to hold the bottom left position and the top right position. We will make it a public static vector 2. The public is necessary so that we can access it from any other script, and the static allows us to access this information without even having a reference to Game Manager, which will make our life easier. It is important to know that the screen position is not exactly the same as the world position, so we'll need bottom left to convert from the camera's screen position to the world point using the camera.main.screen to world point function, and we will pass in the screen point, which is just 0, 0, and that should be the bottom left pixel of our game. So essentially this function will convert the pixel 0, 0 into the world position of the game. And we can repeat this exact same procedure for the top right variable. We can do that using screen.width and screen.height given by Unity. Now let's actually use these values that we just defined in our paddle to set the positions. So let's switch over to the paddle.c# script and just create a variable that holds the position. We will initialize this vector variable to just 0. The right paddle will be placed on the right edge of the screen, which we can now get using our top right variable defined in Game Manager. Because it's static, we can just type GameManager.topRight.x, and this gives us the right world position that we want. However, since position is a vector, we will need to create a new vector. We can't just give it a floating value. So we will set its y value to 0, which is the center vertically. Similarly, if it's a left paddle, we will set its position to the left edge of the screen. And finally, we will set the transform position of the paddle to position. If you haven't noticed yet, transform is a component attached at the top of every game object in Unity. If you want to change the position, you can go to the script and say transform.position is whatever vector you want to set it to. In this case, we set it to position. Let's see what the script actually does by hitting run. You will notice that the paddles are going off the edge a little bit, and that's because what we've done is move the center to the edge of the screen. But we don't want to do that. We want a little bit of an offset. We can achieve this by literally adding an offset to position, and in this case our offset will just be the width of the paddle. You can change it to whatever you want. So we'll add it to the transform local scale x value, which is just the width, and we'll multiply it by vector2.right, which is just the vector 1, 0, which converts this thing into a vector. with 0 on the Y component. And we should repeat that for the left paddle. Of course, on the right side, it shouldn't be a plus, but actually a minus, because we want to go a bit to the left, not a bit to the right. Let's go back and check if this change fixed our problem. We'll hit run, and what you'll see is that indeed the paddles are now in the right position. Next, we want to be able to actually move the paddle as well as collide with the ball. So the way we're going to do that is we'll need a variable for the speed of the paddle that we can adjust, and the variable for the height of the paddle to detect collision. If the ball is within a certain height, then we will collide with the paddle. We already know what height is. It's transform.localscale.y, so we can just set that. But height makes it a little more readable in our code when we use it later. And we can initialize speed to whatever we want. For now, we'll just make it 5. Now we will need to actually get keyboard input, and we'll do that by creating a string for input. We'll also need a boolean, which we'll call isRight, because depending on whether the paddle is on the right or left, we will need to behave with collisions differently. Then when we initialize, we will tell it whether it's a right paddle or not. We can actually get that information directly from the isRightPaddle parameter that we're given. The reason input is a string is because of the way Unity handles input. So switch over to the editor and go to Edit, Project Settings, and Input. You will see a whole bunch of inputs already defined under axis, but we only need 2. One for paddle left and one for paddle right. So we'll rename horizontal to paddle left and do the same for vertical, change it to paddle right. You will notice that Unity uses the word axis for handling input, and the reason that's the case is because it will return a value between +1 and -1 if you try to use it. If you press the positive button, it'll give you a value of 1. If you press the negative button, it'll press the value -1. In our case, we want paddle left to go up when we press W and down when we press S. And now we just need to repeat that process for paddle right. In this case, down is negative and up is positive. So to sum up, here's a review of everything I've done so far in input. Make sure everything is spelled right, because that really matters later on when we code things, and it could be a source of why things don't work. Next, go back to the paddle script, and depending on whether we're the right paddle or not, set the input to the correct value, which should be exactly what we just said in the input manager access. So paddle right for the right and paddle left for the left paddle. Just for readability purposes, we will also set the name of this game object paddle to the input name, which is just either paddle left or right, so we know which paddle is which in the hierarchy. So now we're ready to run this. Just hit the run button, and you'll notice that well, we can't really do anything yet because we haven't actually written the code to move the paddles. All we've done is received input. But you can see that we have the names now. The paddles are named paddle left and paddle right respectively. To move the paddle, we will go to void update, which is called every frame, and first receive input by a float variable move, which is set to input.getAxis with the axis name, which is just input. Note that this will give us a value between -1 and 1. We'll then multiply it by time.delta-time, which is really the same as dividing by the frame rate. This makes sure that our input is frame rate independent. Otherwise, if our frame rate is really fast, the paddles will move abnormally fast. If the frame rate is slow, it will appear to move really slowly. We don't want the user to realize what the frame rate is, or at least we don't want the game to be impacted by the frame rate. Therefore, this is very important. And finally, we will multiply by speed, which is just a constant we defined before to be 5. All we've done so far is define a variable. To actually move the paddle, we use Unity's translate function and convert the floating number move to an up or down vector by multiplying it to vector2.up, which is just 0, 1. Now we've successfully made our paddle move. Let's check by switching over to the game editor and hitting the run button. If you did everything correctly, you should be able to move the right paddle using the up or down key, and the left paddle using the W and S key. As you can see, moving the paddle feels a little slow right now, so what we will need to do is change the speed variable. Now Unity has a really handy way to do that. One thing we could do is make the speed variable public, which allows us to edit it in the editor, but there's a slight problem in that it's now available to every single other C# file, so instead we'll make it serializable by putting the tag serializable field above it. If you click on the paddle game object now, you'll notice that there's a field called speed under the paddle script, which we can now edit, and this is because of serializable field. Let's set it to 10, which is a bit faster than what we had before, and see how that goes. This feels much better. You can actually update this in real time. Well, you'd have to click on the actual instance of the paddle, not the one in the project. There you go. 100 is obviously too fast, and 1 is way too slow. This is cool because it makes it really easy to quickly check which values are correct. Let's just settle for 10. You may notice that right now, if we hit up too long or down too long, the paddle will actually go out of bounds. So what we should do is restrict movement. If the paddle is too far up or too far down, just set move to 0. So we can do that by writing if the transform.position.y is less than the game manager's bottom left y position with a little bit of offset, then set move to 0. And in fact, we'll need to make sure that the move is already less than 0, i.e. that the paddle is already moving down, so that we don't get weird bugs. We need to add height divided by 2, because remember, the x and y position of the paddle is actually in the center, but we want the bottom to not go beyond the bounds. And now we should just repeat the exact same thing for the top. All you need to do is just invert the less than sign to a greater than sign, and all the pluses to minuses. And most importantly, don't forget to change bottom left to top right. And we should now be ready to hit the run button. As you can see, the paddles are now restricted by their walls, but they're moving a little too fast. I think we forgot to reset the value to 10 in the paddle, so let's do that. And now it's behaving like normal and colliding with the boundaries as expected. Great, so that completes the code for moving the paddle. Let's now move the ball. You'll notice that the code we write will be very similar to how we move the paddle. So switch over to the ball script. We will need a variable for the direction of the ball, as well as the radius of the ball, and like with the paddle, we'll also need a variable to hold the speed of the ball. Just like with the paddle, I'll make the speed of the ball serializable so we can adjust it in real time to whatever we want it to be. So at the start of the game, we will set the direction to be with the vector 1, 1, which is just towards the top right of the screen. We'll also need to normalize the vector because the vector 1, 1 has a magnitude of square root of 2, which will later interfere with our speed calculations. So we'll need to make sure the magnitude of the vector is set to 1. The radius will just be set to width divided by 2 or height divided by 2, whichever one you prefer. It doesn't matter because the ball is a perfect circle. To actually move the ball, we will go into update and again translate the ball by the direction times the speed times time.delta time, which will again adjust for changes in the frame rate. We also need the ball to bounce off the top and bottom of the boundaries. Our condition will be exactly the same as the conditions for the boundaries of the paddle, except instead of setting the ball's speed to 0, we will invert the direction. We will set it to the negative direction so that the ball, when it's going up and hits the up boundary, it'll actually start going down. Great, so we can now test this. But before we test it, make sure to set the speed of the ball to a non-zero value. In this case, let's just choose 2. And now we can hit run. As you can see, the ball is now moving to the top right. When it hits the top of the wall, it goes down. But what happens when it hits the right wall? Absolutely nothing. It will go on forever. We need to make sure the other player wins if that's the case. So for now, for the purpose of this tutorial, all we'll say is that if the ball is out of bounds on the left side of the screen, then the right player has won. Otherwise, if it's out of bounds on the right side of the screen, then the left player has won. To do this, I will just copy and paste the same conditions for the top and bottom, but change all the y's to x's. Make sure to do this correctly because this is a source of a lot of bugs in coding. In general, copying and pasting is not a good idea, but I'm lazy, so I'll do it. So if the ball is too far left, then we know that the right player has won. And for now, we'll just print it by saying debug.log right player wins. And we will copy and paste that code for the other side. If the ball goes too far to the right, then the left player wins. Again, make sure to flip everything properly. The last step is to actually check if the ball collided with one of the paddles, and depending on which paddle it hit, we should change the direction of the ball. Unity actually gives us a handy function for that called onTriggerEnter2D. Now remember, in the beginning of the tutorial we gave both the ball and a paddle a collider with trigger enabled. We also gave it a rigid body 2D component with kinematics enabled. So you need both of those things on both game objects so that this works. So please make sure you've done both of those things correctly. You will also notice that this function has a parameter of type collider2D called other. This basically lets us know what has collided with the ball. And in this case, we need to check if we've collided with the paddle. So if the other game object has a tag of paddle, then we know we've collided with a paddle. Now you'll recall that our paddle has the tag paddle attached to it. Make sure that is the case, otherwise collisions won't work. So the next thing we need to know is this a right paddle or a left paddle? So we'll create a boolean called isRight, and what this will do is ask the paddle, hey, are you a right paddle? And we can do that by saying other.getComponentPaddle, which gets the script paddle, and then we check the variable isRight. Now you'll notice we don't have access to it, so we'll need to go back to the paddle script and make the isRight boolean public, so now we can access it from the ball. Great, so now if we collided with the right paddle and we're moving towards the right side, then we will just invert the direction. We'll go back to the left side. And similarly, if we collided with the left paddle and we're moving towards the left side, then we'll set the direction of the ball to the opposite direction, so it goes back towards the other paddle. At this point, the game is almost complete. All we will now need to do is some testing and tweaking. So let's hit run, and well, I see that the ball is moving really slowly, so we should probably change that. Instead of moving at a speed of 2, we should move at a speed of, let's say, 6. Thankfully, we can make this change by just clicking on ball and changing its speed to 6. That's it. And as you can see, the ball is much faster, which makes the game far more interesting. So right now, we just saw that both the right paddle and the left paddle collisions worked. And if everything works correctly, when the ball goes out of bounds on the left side, right player should win. And indeed, in the console we see that the right player has won. But the game is still going on, so what we should do is just stop the game right there. Otherwise it'll print it forever, which is kind of bad. So to freeze the game, we can just type time.timescale = 0, which just freezes time. In addition, we will also need to disable the script, which we can do by just typing enabled = false. Enabled is a variable that is inherent to all script. If you set it to true, it turns on the script, and if you set it to false, it turns it off. So that's what we will do to stop the update loop from happening. So now if we hit run, and if the right player misses the ball, then it prints left player wins only once and freezes the game as expected. That completes the tutorial. If you liked it, hit the like button, and if you have any questions or suggestions, please feel free to write it in the comments. Stay tuned for more tutorial videos, and see you next time.